Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials V6, or the Networking 2 course at AACC, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 2.2.4.4, where we build and sort of repeat what we did in activity 2.2.2.4 with IPv4. We're now going to be creating IPv6 static and default routes. So let's dive into this activity. It should look very familiar. The actual topology is identical to what we were working with, but we've got some additional things we need to take into account now, namely IPv6 addressing as opposed to IPv4. So we're going to dive right in here. So looking at the topology diagram, how many networks are there in total? Well, the answer is the same as it was before. We've got 5 networks in total. We've got the 2 transit networks here between the routers. And then behind the routers, we have 3 networks, and we'll just say colon 1, colon 2, and colon 3. So 5 total. How many networks are directly connected? This answer is the same. So router 1 has 2 directly connected, router 2 has 3 directly connected, and router 3 has 2 directly connected. How many static routes are required by each router to reach the networks that are not directly connected? So same answer as before, it's going to be 2, because we need not only the route to get there, but we also need the route to get back. All right. Next question. Which command is used to configure IPv6? And hold on just one second here. All right, and so which command is used to configure the static routes? Well, it's the same command that we saw before with a minor twist. We're dealing with IPv6, so we're going to have to say IPv6 route, and then indicate the IPv6 address that we are interested in using. I think I'm going to leave it right there for the entire activity. So here we go, part 2. Again, this is almost a carbon copy of what we did on exercise Packet Tracer 2.2.2.4 with IPv4. We're just using IPv6 now. So enable IPv6 routing on all routers. So let's pull router 1 up, and let's get to the CLI. And what is the command? So we're in user exec right now. So if I was to try to say IPv6 unicast routing, what's going to happen? Yeah, we're going to get invalid input because this is a configuration command. So we need to go from user exec mode, as evidenced by the greater than sign, use the enable command to get into privilege exec, and then into global config, and then say IPv6 unicast routing. Remember that with IPv6, IPv6 routing is not enabled by default on Cisco routers. Now, this may change someday, but as of right now, that is the default. So we'll take care of router 1. We'll come over here to the CLI on router 2, and we'll do the same thing. We'll get into global config and say IPv6 unicast routing, and then now let's enable that on router 3. So we go from user exec to privilege exec, and then into global config and say IPv6 unicast routing. All right, so we've enabled unicast routing on all of the routers. And which command accomplishes this? IPv6 unicast routing. Enter the command on each router. We did. All right, configure an IPv6 recursive static route to every network not directly connected to router 1. And so we are well schooled, whoops, and I did not want that. We are well schooled on what is required, or what that means, the recursive static route. So router 1 is directly connected to 2 networks, the 2001 DB81A 001, and then 2001 DB8:1:1. So we need 1, 2, 3 recursive entries, just like we did with the IPv4 setup. So I'm going to say IPv6 route, and we'll take care of the router 2 network. So my IPv6 route to get to the 2001 DB8 and this is not case sensitive, :1, :2, : /64 is to go to the next hop IP address on router 2, right here, router 2's serial 000 interface, and it is conveniently just :2. So we're going to say 2001 : DB8 : I got to look back up here, 2001 DB8 : 1 : A001 : 2, and that is, and hold on one second here, whoops, /64, what did I do wrong? I thought we had that was right. Maybe something was wrong in my address. 2001, oh, there was something wrong in my address. I was missing that final colon there. So let's actually call that command back up, save ourselves a little typing there. And it's one of the hazards of having to look to the addressing table and then to look back down into the CLI prompt. So there is our first recursive route. Now we're going to save ourselves some time because that next hop IP for all 3 recursive entries doesn't change. So what's one of the differences that you notice? Exactly, I can use the prefix length here. I could not use the CIDR notation with IPv4, but with IPv6, there is no concept of a dotted decimal notation subnet mask, right? We have a prefix and a prefix length, and therefore we're able to enter it in here. So it's actually really convenient with IPv6. There's obviously some more typing to get those hexadecimal characters in there, but it saves us a little time right here. So this will be easy because the network behind router 3 is 2001 DB8 : 1 : 3 : /64. And then we need the transit network segment, which is going to be a little different here. DB1 : and this is going to be A002. All right, so we should look over here to the right, the lower right, and see that we have 30 out of 60 points, which we do. So configure a recursive static route for every network not directly connected to router 1. We did that and everything looks great. Now we're going to configure a directly attached and fully specified static route on router 2. So configure a directly attached route from router 2 to the R1 LAN. So let's pull router 2 up here, and we'll move that a little higher. So we're going to say IPv6 route. So my IPv6 pathway or route to get to the 2001 : DB8 : 1 : 1 : /64 is going to be to go to the next hop, which is going to be, and I'm sorry, this is directly connected. Yeah, directly attached. So it's going to be out serial interface 000. And that is the directly connected entry. All right. Now we're going to configure a fully specific or specified static route from router 2 to the R3 LAN. Now it says here packet tracer. Actually, packet tracer version 6.0.1 only checks for directly and your instructor may ask to review the configuration. Okay, so that's packet tracer version 6. We're packet tracer version 7.1.1 here. Let's see if I can do a fully specified here. So we would say, and actually we can save ourselves some time, I'm going to pull that up and let's change this. So my IPv6 route to get to the 2001, DB8 : 1 : 3 : /64 network is out that interface to the next hop IP address right here on router 3. Remember, we're fully specifying things. So 2001 DB8 : 1 : A002 : /64. Let me make sure I've got this right. IPv6 route, we've got the 2001 DB8, we've got the outgoing interface, and I'm sorry, I wanted the next hop IP, which is, for whatever reason, it's 2. Okay, so there we go. So that is the fully specified, and it looks like that works. Now, we're not going to get points for that. For whatever reason, it's not going to give us the points, and that's okay. So that was that note there. And let me see, only checks for directly attached and recursive static routes. So let me put a recursive entry in here and see if that gives us points. So there's the recursive entry with the next, and yeah, and so that gave us the points. So pretty cool, right? It allows us to put in the fully specified static route from router 2 to the R3 LAN, and again, this is a little repetitive, but in order to get those points so that we can see what's required, it allows us to put the recursive entry in. So now we're going to go to router 3, and we're going to configure a recursive default route, very similar to what we did before. And this is one of the things that kind of throws learners when they see this. So Ipv6 route : /0. And let me double check because I believe it said configure a recursive default, so recursive default route. So we're going to need that next hop IP here, which is 2001 : DB8 : 1 : in between routers 2 and 3, it's A002 : 1. So that is the recursive default route entry on router 3, and we should get awarded those 10 points, and we do. So let's talk about this. Which command is used in Packet Tracer to verify the Ipv6 configuration of an IP from the command prompt? And this question, I believe Lauren had brought this up in an email to me. And let's take a look at this because this is critical to being able to complete these activities successfully and answer a lot of the questions that you see throughout the text. So if I say ipconfig all, what does that give me, right? So you can see if I had IPv4 addressing, it would give it to me. It gives me the link local IPv6 address. And you can see here's the IPv4 information that would be mixed in there. And then the DHCP-v6 client ID, and that's out of our scope. So, but what do we get? We get a link local address. And then if there was IPv4 addressing, if it was a dual stack client, we would see the IPv6 information here. I'm sorry, the IPv4 information here, but we don't. We see an IPv6 link local address, and we see IPv4 information. Where is the IPv6 global unicast address? Where is that at? Well, how would we check that? I wanted to come right back here. Let's come right back here. What if we said IPv6 config -all? And again, you'll notice there's kind of a pattern. Whereas before, it was always IP something, right? Show IP route for IPv4. Or IP config for the IPv4 information, even though it did trickle a little IPv6 info in there. But in order to see the global unicast address, right, that publicly routable address, we need to make sure that we see that we use IPv6 config. So that's the command that's required to get that information. Which command displays the IPv6 addresses configured on a router's interface? Well, we know that if there were any IPv4 addresses, we would say what? Show IP interface brief, right? And that shows us if there was an address, it shows us the layer 1 status, the layer 2 protocol status, right? But here it's simply show IPv6. So again, simply substituting IPv6 or appending v6 onto the previously used IPv4 command sets. And then last but not least, which command displays the contents of the routing table? So if it was IPv4, it would be show IP route. But again, this is a non-dual stack environment. Everything here is IPv6, so I would say show IPv6 route. And it shows me my statics with the S, it shows me my directly connected, and it shows me my local /128s, right? This is equivalent to a /32 host route, right? But it's a 128 because there's 128 bits in IPv6 addressing. All right, well, this is going to wrap up, and again, much briefer than the IPv4 conversation because we defined a lot of the terminology, and it's the same in terms of the directly connected, in terms of the recursive, and in terms of the fully qualified static routing. All we're doing here is basically substituting IPv6 for IPv4 in order to make things work. All right, well, this is going to wrap up Packet Tracer Activity 2.2.4.4, where we took a look at IPv6 static and default routes. Thanks for watching. Enjoy your weekend, and I will talk with you soon.